Thank you, sir. I hope I can do justice to that introduction. It's not on the screen. Oh, okay. So Climate Policy Initiative Energy Finance has been working on almost a multi-year program looking at different aspects of the electricity sector in India. We started with the first year focused on and working in collaboration with two of our consortium partners under ETC India, TERI, which looked at demand and supply scenarios to 2030 on which our flexibility analysis was based, and NREL, which has then gone and done further analysis, taking into consideration some of the flexibility scenarios that came out of our work and running them through Plexos models. So, and David obviously is present here, who's been leading that charge. So our first year work was focused on looking at, as we factor in more renewables, looking at the government's ambitions through the policy for 175 gigawatts by 2022 or 275 by 26, 27, and then following that trajectory onwards, how does the flexibility requirement, the reserve requirement, ramping requirement, daily shifting requirement, seasonal shifting requirement, how does all of that kind of start moving? What do we need to get into place to be ready for adding all of this renewables in? We looked at three scenarios. Apart from the scenarios on current policy, we looked at the current trajectory, which is trailing behind current policy. And we looked at, so instead of the about the 320 gigawatts that you would end up at 2030, under the current policy, you'd end up closer to like 270 gigawatts under the current trajectory scenario. And we also looked at a more ambitious renewable energy scenario, looking at around 390 gigawatts of solar and wind energy addition into the system by the time you get to the to 2030. And some of the key takeaways from analysis was increasing electricity system flexibility will reduce costs. Even before you start getting focused on renewables, just managing the changing profile of demand, managing the changes that are happening in the India electricity system, adding more flexibility reduces costs. India's system flexibility needs are growing. Our consumers' consumptions are increasing. We're adding more appliances in our house. The peak happens in the evening with everybody switching on their requirements at the same time. We are adding more intermittent capacity into the system. We have multiple sources of flexibility that are available and will be required to meet India's needs. At the moment, most of our needs are met through power plants. But with the way the power plants are currently providing flexibility, and just through that source, we will not be able to meet all our flexibility needs by the time we get to 2030. And integrating all of these diverse sources, and we'll go through the sources that we looked at as we go through the presentation, but looking at all of these diverse sources requires new types of incentives, infrastructure, markets, investment, a little bit of a different kind of thinking to integrate a new electricity system. So in terms of the first point that I mentioned in terms of the impact on cost, so under the current trajectory scenario, if we were to not get much more ambitious than where we stand and just follow the current trajectory, if you're able to if you're able to enhance the flexibility that we can get from our power plants by addressing some of the technical minimum issues, changing some of the operational profiles, if we are able to tap into demand response, which in India at the moment is mostly at pilot stages. There have been quite a few pilots done spread across different parts of India, but there is no actual large-scale program on demand response in India actually happening at the moment. And we are able to integrate more of storage into the system. We can actually reduce the overall system costs. So enhanced flexibility reduces costs. We can carry this advantage even if we were to increase our ambitions. So if we move on to the high renewable energy scenario that I mentioned earlier, we could still keep our system costs very similar to what we can under current trajectory. But if you're not able to do that, high renewables will come at a massive expense. We will have peak shortfalls, which either will be met through much more expensive resources. We could tap into existing backup systems that exist, including diesel gensets, or we need to add more supply side resources, both of which would be more expensive. This kind of shows it more granularly across different kinds of flexibility needs that we have in the system. So if we look at the operating reserves or the ramping requirements, we are safe at least for the next 7, 8 years, but actually not really so, because many of the states will start experiencing these issues much before the country does, because there is an averaging that happens when you look at India as a whole. Some of the renewables, some of the states which are at the forefront of renewable deployment, and we looked at 2 of those, Karnataka and Tamil Nadu, will start facing ramping issues, seasonal balancing issues much earlier, by the time we've even landed into the mid-2020s. And daily balancing could become a massive challenge for the India system as a whole. So even if our demand increase is 2 times, peak increase to 2.2 times, we could see that our daily shifting needs, especially in the high renewable energy scenario, could go up to 6 times, which is 3 times the time of demand. Our ramping needs could go up almost twice the increase in demand. So flexibility needs will be increasing much faster than demand itself, driven by changing demand profiles, changing the consumption profiles of consumers across different segments, and obviously us adding more renewables. So this is another look at it. So if you look at the graphs on the top, by 2017, we are adding renewables into the system, but it hasn't exactly started being a problem. But when we get to 2030, if we are able to achieve high RE ambitions, at least the 390 gigawatts that we've looked at, we see that there is superfluous energy on a daily basis especially in the high wind seasons, where you'll have either curtailment, which means extra cost to the system, or you just need to find a different way of running your system. On a seasonal basis as well, there are certain months of the year, if you look at June and July on the bottom right chart, where we are actually, our coal plants may not need to run at all. So just in way of explanation, the gray part in the bottom right chart is what we call residual generation. So if you look at the demand profile for the year, net it off the variable renewable energy, because that's a must-run capacity. What's left is what will be met through other capacity, including coal and hydro, and the variable capacity left on hydro, because some of the hydro also runs as must-run because of agricultural considerations, water flow considerations, etc. So flexibility needs will arrive sooner, be much more significant in states. We looked at 4 states, 2 renewable energy heavy states, so Karnataka, which has a lot of solar in its system. It is, if I remember correctly, it has already met its renewables obligations requirements as we stand, and the minimum renewable obligations requirements, obviously, but, and Tamil Nadu, which is the highest wind energy state in the country. So here we see that by the time we have gotten into the mid-2020s, there is a lot of excess generation here. So this graph on the left top basically shows excess generation as a percentage of variable renewable energy being generated. India kind of stagnates at around 5 to 7%. Karnataka and Tamil Nadu are 3 times that. Addition of solar in Karnataka will also mean that ramping requirements in Karnataka are also increasing about 3 times faster than they are in India. If we start looking also at the 2 states which have more of their portfolio coming in from conventional generation, we don't see them varying very much from what it is in India, but the profile of run for the existing conventional generation capacity that exists in Tamil Nadu, Karnataka will be a lot more stressed. So both of these states currently run at technical minimums of 70% for coal plants. But you see that by the time we are into our 2020s, the PLF of the residual generation or the conventional generation falls down to 30, which is a lot lower than what we see from an India perspective. And so the top right chart is the annual plant load factor in these states, whereas the bottom shows us the maximum and the minimum. And this is important because when we look at Tamil Nadu, we will see that in the periods where wind is maximum, there are a few months in the year where Tamil Nadu doesn't need to run its thermal capacity at all by the time we reach 2020s. So which is the bottom 0 part of the Tamil Nadu chart here. So India has new options beyond existing power plants, flexible demand and storage to meet flexibility needs by 2030. At the moment, demand side doesn't exist. Storage, there have been a few pilots happening. There is one in Delhi, there is one in Andaman, and there are a couple of other programs coming up. But none of that, but it's not present in size in India. But by the time we get to 2030, strategic deployment of demand-side storage, bringing in the volumes, would help us to meet most of our flexibility needs. Storage could help us meet the reserve needs, ramping requirements. Power plant can, enhanced flexibility from power plants, rather, could help us meet all 4 of our flexibility requirements. And demand side could definitely help us meet cost-effectively our requirements on operating reserves and daily balancing, which become quite austere by the time we reach 2030. Here, so when we looked at the various options for flexibility, what we did is we looked at the potential volume of flexibility, potential load that, for demand side, we looked at potential load that it added into the system, how much of it could potentially be flexed, and what would be the cost in terms of the capital expenditure needed to operate that, to get the flexibility, as well as any operating costs involved. So we built supply curves on that basis, mapping demand side resources, storage, power plants, with and without retrofits. And you'll see that by the time we are getting to 2030, demand side is an integral part of meeting our daily balancing needs. Our reserve needs are quite effectively met through most of the power plant capacity that exists today as well as in 2030. But demand response becomes quite important by the time we reach 2030 to meet our needs effectively and at low cost. Battery costs are declining rapidly given the electric vehicle market. But if you look at the chart on the right-hand side, you see that energy storage projections with regards to the growth of participation of storage in the energy sector isn't that positive. Part of that is because even though the costs are declining, they're not declining fast enough. And if we look at our supply curve as well, storage is more on the expensive side in meeting some of the flexibility needs. This chart looks at the daily flexibility needs being met by different technologies. However, if we were to stack values which are met through storage, we could be able to reduce the overall cost to meeting different kinds of flexibility needs and make storage, battery storage more cost effective, more sooner for the India electricity system. Existing power plants, again, cost effective source of flexibility. They are the go-to source for meeting flexibility in the electricity system in India as we stand today. However, they will continue to play an important part going forward, but they become more relevant if we are able to make some of the changes that are necessary to get the enhanced power plant flexibility. So what does that mean? It means certain plants need to be retrofitted and they need to be able to recover costs. Any operational changes that come with operating plants more flexibly should be recoverable. So power plants will continue to play an important part in the flexibility of India electricity system as we go forward. This, I am told, is a slightly controversial slide because it looks at the role of diesel gensets in flexibility. We're not looking at adding any new capacity in terms of diesel gensets in the system, but in the interim, as India gets its capacity on demand, so it gets its operations and systems and market structures in place for demand response. As it goes about figuring out where storage fits in, factoring in the trade-offs with other options that it has. In the intermediate, there is existing capacity both behind the meters and on more commercial scale in form of diesel capacity, which could provide fulfill some of the balancing needs that are required by the India electricity system. Sorry? So once we had looked at individually how the various options, technologies could meet the flexibility needs in the India electricity system, we decided to look at how they all come together. Now, the cost and the construction of the portfolio of these flexibility options will be driven by how ambitious are we on our renewable scenarios, and how much of demand response can we really translate into reality. Because those are about changing behaviors and it is one of the most cost-effective ways of meeting our flexibility solutions. And that will have significant impacts on how system costs and costs of flexibility evolve as we go towards 2030. So this is one sample of how the construction of the flexibility portfolios could impact system costs, could impact the stresses on different participants in the electricity system. So if we look at the right-hand side chart, that is looking at obtaining entire set of flexibility requirements just from power plants, thermal power plants that exist in the system by the time we get to 2030. You'll notice the dark and the light gray at the bottom, towards the bottom of the chart, show a lot more variation, which means our coal plants are a lot more stressed. And on the top, you'll see that there is more of yellow beyond the, I don't know if you can see the color, but the dark blue line or the bold line on the top, which means there is spillage, curtailment, wasted energy, whatever term keeps us happy there. Instead, if we were to build a portfolio of options comprising power plant flexibility, storage, demand-side response, we are able to deliver the same kind of system reliability by flexing our coal plants a little less, wasting less of the energy, so only the tips of the yellows are now wasted. And that means lower system cost, lower cost of procuring this flexibility by combining the various options. So a portfolio approach to building the setup to meet our flexibility needs as we add more renewables, as the demand profile becomes peakier without interventions towards 2030 is a more cost-effective way of maintaining a reliable, decarbonized electricity system. Now, this is a comprehensive download of all the portfolios that we considered. So from top to down, you see, as compared to base case, we have power plant-driven flexibility, demand-side-driven, storage-driven, and balanced portfolio. Balanced portfolio being the combination of the top three. And we see that we can reduce excess energy or curtailment by up to 97%, even in the current trajectory scenario. And even within the high renewable scenario, that's 80% plus. We still manage to get carbon reductions down by 8 to 12%, and the maximum in the balanced portfolio scenario because we are not adding any more supply-side generation capacity here. And this is looking at, in a slightly more consolidated way, the four states that we decided to look at for case studies. Now, we have highlighted before how certain flexibility needs become a lot more prominent in the states of Karnataka, where you are adding a lot more solar. Even with Karnataka having met its minimum RPO requirements, there is still talk of adding more distributed solar, even though their utility scale solar has been, for the moment, it's being considered to be put on hold. Tamil Nadu, where we are looking at a lot of wind capacity in the system. So the stresses that they bring, the flexibility needs, growth that they bring into the system, there is a balance for that available within the country across other states. So you have Uttar Pradesh, which meets most of its energy requirements through contracted conventional capacity. There isn't, partly because of resources, the renewable resources predominance in other parts of the country. The Uttar Pradesh focus on renewables is comparatively muted. We believe that if states like Uttar Pradesh and Bihar were able to tap into flexibility as well, they would, one, be able to solve some of the challenges that exist on the ground in terms of energy reliability, security. So converting involuntary load shedding into voluntary load shedding, which is you incentivize people to actually shift their demands by using the storage capacity that they have or by using other means to move their demands at other points of time. And a state like Uttar Pradesh, which is able to meet most of its requirements today through the contracted capacity it has, could even be a flexibility exporter to states like Karnataka and Tamil Nadu, which will need to find increasing amounts of flexibility as we go into the 2020s and 2030s and beyond. Sorry for that. So our analysis told us we need more flexibility as we go forward. We have multiple options. We need to develop them till 2030. But what needs to happen to make all of this possible? It's a combination of greater amounts of data, because if you want to understand what your flexibility opportunities are on the supply side, on the demand side, you need to be able to see how people are consuming, how you're supplying, and how you can find the trade-offs. To be able to find how you can incentivize demand response, you need to be able to have the data to be able to monitor the impact that your incentives, pricing mechanisms, et cetera, are having. You need more technology to be able to monitor, pass on directions, and actually be able to get responses from your consumers. Even from storage, to be able to get real-time responses from them, you need technology, smart technology for demand response, for example. Infrastructure, awareness, new business models, retail consumers' participation in demand response can be vastly accelerated if we have participation of market, time is over, sorry. If we have addition of aggregators in the model. So bringing all of this together, market design is one thing we realized and looking at how that can be brought up to speed to deliver the new flexibility resources was one of the key aspects to take forward. Market design would need to look at the long-term questions, ancillary services, how do we plan to achieve, maintain, and grow a reliable energy system at low cost, as well as the intermediate transition questions. So in the immediate future, in the medium term, how you develop the technologies, how you overcome entrenched practices, and facilitate transition. And this is, I'm going to leave it on the screen rather than spending too much time, but this is one illustration that we had thought we'd take you over, which is how do you build the end-use case for batteries? What needs can it serve? What are the trade-offs with other technologies? So how do you set it up in terms of efficiency requirements, charge, discharge efficiency, response time, cost? What would you need to kind of integrate it into the system in terms of pricing mechanisms, incentives, development of battery manufacturing in India, or bringing parts of the value chain? And how do you build an investment case around it? Whether it's the utility trying to make the investment, you want to bring in institutional or strategic investors, consumers, reduce financing cost, assure return on investment, payback periods, regulation and supporting policy framework. So this is the work that we are doing with 3 states in India at the moment, trying to address the challenges that they are facing today and also in the medium term to come up with market-based solutions to enhance more flexibility and bring more efficiency into their respective electricity systems. Thank you, and sorry for going over time.